The moon is our eternal companion, which seems so familiar, yet actually hides many secrets. We only see one side of it, while the other, the far side, remains a mystery. What lies beyond the horizon? Mountains, taller than Everest, craters that could swallow entire cities, and darkness where light does not reach. Telescopes and probes continue to uncover amazing facts. Minerals older than Earth, traces of ancient magnetic fields, and even ice in perpetual shadow. But why does the moon so carefully hide its secrets? Today, we will venture to places where no human has set foot to discover the truth about Earth's most mysterious neighbor. The Soviet breakthrough, Luna 3. 1959. The Cold War is in full swing, and the USSR achieves the impossible. The Luna 3 station photographs the far side for the first time. Scientists, upon seeing the images, can't believe their eyes. Instead of smooth plains, there are mountains, twice as high as Everest, and craters that look like scars from cosmic catastrophes. But why are the two sides of the moon so different? The visible side is covered with basaltic seas, while the far side is like armor, guarding a secret. Soviet researchers joked, even ghosts would be bored there. But now we know the silence is deceptive. Beneath the layer of regolith, there might be caves with ice, traces of ancient eruptions, or even minerals that could rewrite the history of the solar system. Luna 3 provided the first answers, but it raised even more questions, and we have only just begun to read its first pages. The Webb telescope anomalies in the shadow. In the 2020s, the James Webb telescope directed its mirrors into the eternal darkness of the far side. What it saw astounded scientists. Among the craters and mountains, structures were found that don't fit into any textbook. Plateaus of minerals that shouldn't be on the moon, and traces of magnetic fields dozens of times stronger than Earth's. Even more questions were raised by anomalous zones with increased soil density, as if voids or ancient lava tubes are hidden beneath them. But the strangest thing is the traces of ice in craters where the sun never shines. Where does water come from in a world where the temperature drops to minus 400 degrees Fahrenheit? Scientists whisper, it's like finding an oasis in the Sahara Desert. Could the ice be a legacy of comets that bombarded the moon? Or was water born in its depths during eruptions? The Webb telescope doesn't provide answers, but its data is the key to a door behind which a new chapter of lunar history is hidden. Soil samples are time capsules. In 2020, the Chinese probe Chang'e 5 delivered samples from the far side of the moon to Earth. Their analysis overturned everything we knew. The soil turned out to be 1 billion years older than samples from the visible side. It is almost 4.5 billion years old. They found volcanic rocks rich in oxygen and minerals that only form under extreme pressures, as if the moon had experienced a cataclysm that compressed its crust. But the main sensation is the traces of helium-3, the ideal fuel for thermonuclear reactors. Its concentration here is 10 times higher than on the bright side. Why? Scientists suggest that the far side, unprotected by Earth, has been bombarded by the solar wind for billions of years, which left these deposits. But how is there so much helium-3 if the moon is dead? Every gram of this soil is a message from an era when planets were just being born. By studying it, we are not just reading the past, we are searching for keys to the future. After all, whoever controls helium-3 controls the energy of the stars. But is humanity ready for such responsibility? Ice traps. In the eternal shadow of polar craters, where the temperature drops to minus 400 degrees Fahrenheit, probes have discovered ice. It's like an oasis in the desert, but instead of water, there are frozen molecules that have survived billions of years. How did they end up here? One theory suggests that comets brought the ice, bombarding the moon and leaving their tears in the cold traps. Another version is that water was created right on the spot when the solar wind collided with lunar minerals, releasing oxygen and hydrogen. But the most intriguing part is the traces of organic compounds found near the ice. Or is it just contamination from Earth probes? There is no answer yet, but these ice reserves are already being called gold for future colonies. Water is not only for drinking, but also a source of oxygen and a component of rocket fuel. But how do you extract ice from craters where light doesn't reach? Perhaps mining robots with lasers will become the new conquerors of the lunar darkness, unless, of course, it hides something dangerous. Magnetic ghosts. The moon today does not have a global magnetic field, but in the samples. As if they were captured by a force comparable to Earth's. How is that possible? The answer lies in the distant past. Billions of years ago, when the moon was younger, Its core might have churned like Earth's, creating a powerful magnetic field. But what caused it to stop? Theories vary: a giant asteroid impact, the cooling of the core, or mysterious processes in the mantle. Even stranger is that these magnetic anomalies are concentrated specifically on the far side. Could it be that once the moon, like a shield, exposed it to cosmic bombardment, and the magnetic field tried to protect the surface? Or are there ancient rocks hidden here that have preserved the memory of times when the solar system was young and chaotic? They make you wonder, what if the moon wasn't always dead? Perhaps beneath its crust, embers of past activities still smolder, ready to awaken. Gravitational embrace. Why does the moon always show us only one side? The answer lies in a gravitational dance that has lasted billions of years. The Earth, like a giant magnet, pulled the moon in such a way that its rotation around its axis synchronized with its orbital movement. But this is not just a coincidence. Scientists call this tidal locking. The force of Earth's gravity stretched the young moon, slowing its rotation until it matched its orbital period. However, there's a paradox here. If it were that simple, the far side would have become visible long ago due to oscillations. Could this be the result of an ancient impact that split it into two halves? Or is there still an asymmetrical core hidden within its depths, acting as a gravitational anchor? Astronomers debate, but the fact remains we are bound to the bright side like prisoners, while the dark half continues to keep its secrets. What if synchronous rotation is not a natural phenomenon, but a shield protecting us from something better left undisturbed? The first landing, the illusion of control. July 20th, 1969. Neil Armstrong makes a giant leap for mankind. The world rejoices, but the main point remains behind the scenes. The astronauts only explored the visible side, the one always facing Earth. Beyond the horizon lies the unexplored part of the moon. Apollo 11 brought back soil and left mirrors for measurements. But all of this is only on the bright side. Why did no one dare to look further? Even today, half a century later, the far side remains terra incognita. Craters that could swallow cities, mountain ranges tearing through the landscape, and silence, a deafening, all-encompassing silence, undisturbed even by radio waves from Earth. What lies hidden where no human has set foot? Comets and volcanoes. The debate over the origin of lunar ice has divided scientists into two camps. The first group is convinced that comets brought the water. Their traces, hydrogen isotopes in the soil, match the data on ancient icy travelers. But then why is ice only found in shadowed craters? The second group insists that water erupted from the moon's interior during volcanic eruptions and then got trapped in cold traps. The evidence is the glass beads in the soil that have preserved traces of water. But how could volcanoes create so much ice if the moon is considered geologically dead? The third, boldest option is that water has always been here since the satellite's formation. In that case, the moon is not a dry desert but an archive preserving the moisture of the young solar system. Until probes extract samples from the depths of the craters, the debate will remain open. But one thing is clear: lunar ice is not just a scientific curiosity. It is the key to understanding how water, the foundation of life, spreads throughout space. If its source is the moon itself, it means that even dead worlds can be keepers of the greatest secrets. Cave shelters. Beneath the surface of the moon lies a network of giant tunnels, lava tubes left behind by ancient eruptions. These caves, up to 1,640 feet wide, could become shelters for future colonists. Here, there is no deadly radiation, temperature fluctuations, or meteor showers. Data from probes indicate ice deep within the caves and strange magnetic anomalies. Scientists suggest that such cavities might have preserved traces of ancient volcanic activity, or even organic molecules brought by asteroids. But there are also risks. What if the caves are not inhabited by something living, but by deadly gases or unstable rocks? NASA is already planning missions with scout robots, but for now, these tunnels remain a mystery. Perhaps they hold the key to human survival on the moon, or conversely, they might become a trap for those who dare to enter the darkness. The mystery of basalt. Why is the near side of the moon covered with dark basaltic seas, while the far side is almost not? The answer lies in its turbulent past. 3 to 4 billion years ago, asteroids broke through the lunar crust, causing lava to flow, but only on the near side. Why? Scientists blame Earth. Its gravity pulled the thinner crust, making the near side vulnerable to impacts. Lava filled the craters, creating smooth plains. But the far side, with its thick crust, remained scarred from the war with space. There is another theory. Radioactive elements concentrated on the near side, heated the interior, triggering eruptions. But how did the elements become so unevenly distributed? Could it be that the moon formed from Earth's debris after a giant collision, and its sides were different from the start? An impact that changed everything. 4.5 billion years ago, Proto-Earth collided with a Mars-sized body. The impact ejected molten debris into space, from which the moon was born. This theory explains a lot: the similar composition of Earth and the moon, its elongated orbit. But questions remain. Why are the two sides of the moon so different? Could it be that the impact was not head-on but glancing, creating asymmetry? Or did the moon form from two different bodies? Data from probes show that the far side is rich in anorthosite, a mineral that forms in magmatic oceans. This confirms that the moon was once covered by a sea of molten magma. But how did it cool so unevenly? After all, if not for that impact, our planet might not exist, or it might not have conditions suitable for life. The mystery of density. The far side of the moon hides not only mountains but also a mystery of density. Its crust is thicker than on the visible side, in some places up to 93 miles compared to 37 to 43 miles. Why? Scientists suggest that after the giant collision that created the moon, light minerals floated to the surface, while heavy ones sank down. But why was this distribution disrupted? Could it be that Earth's tidal forces pulled the crust to the visible side, leaving the far side protected by a thick shell? Or are ancient magmatic reservoirs hidden that never erupted? The density makes the far side difficult to study. Probe drills cannot penetrate the thick layer of regolith, but it is precisely beneath it that answers may be hiding. What if the thick crust is a shield concealing underground lakes of molten magma or even traces of ancient tectonics? The deeper we dig, the more questions arise. Chinese probe Chang'e 4. In 2019, China made a breakthrough. The probe Chang'e 4 landed on the far side of the moon. The soil in the Von Karman crater contained minerals not found on the visible side, olivine and pyroxene, typical of the mantle. How did they end up on the surface? Likely an ancient asteroid impact ejected them from the depths. But that's not all. The device detected iron-rich rocks with unusual radio signals. Scientists speculate, are these traces of meteorite bombardment or remnants of lava enriched with metals? Chang'e 4 also recorded an anomalous temperature. At night it dropped to minus 310 degrees Fahrenheit, which is much colder than on the visible side. Why? There's no answer. But one thing is clear: the far side of the moon is not a twin of the visible side, but a separate world with its own geology, and each new probe brings more mysteries than answers. On the radio, silence. The far side of the moon is the perfect place for radio telescopes. There are no interferences from Earth here, no cell towers, no satellites, not even an atmosphere. But when scientists pointed the antennas into space, they heard silence. Not absolute, yes, the background noise of the universe, but no signals they were expecting. Where did the radio waves from distant galaxies go? It turned out, moon dust, charged by the solar wind, creates interference. But there are also oddities. In 2022, a radio telescope in lunar orbit detected low-frequency pulses resembling the heartbeat of pulsars. Their source is unknown. Could it be echoes of ancient supernovae, or signals from objects we have yet to discover? Astronomers hope that the far side will become a window into the dark ages of the universe, the era before the birth of the first stars. But for now, the silence here is unsettling, or, on the contrary, the key to unraveling its greatest mysteries. The answer lies in the radio waves that are yet to be captured. Helium-3, the fuel of the future? Lunar soil holds a treasure capable of transforming Earth's energy sector. Helium-3. On the moon, helium-3 reserves are estimated to be in the millions of tons. Why is it so valuable? Helium-3 is the ideal fuel for thermonuclear reactors. When reacting with deuterium, it doesn't leave radioactive waste. But how did it get to the moon? Scientists believe that it was brought by the solar wind bombarding the surface for billions of years. However, extraction is not for the faint-hearted. Extreme conditions make mining difficult. Even mining robots might not withstand it. Will it be the countries that extract it first, or all of humanity? While politicians debate, China and the USA are already developing extraction technologies. Maybe, in 50 years, the moon will become the new Middle East and its dark side. A battleground for star energy? Or will we find a way to share without wars? Colonization, a dream or a nightmare? NASA plans to build lunar bases by 2030. But life on the moon is no vacation. During the day, the temperature is plus 260 degrees Fahrenheit. At night, minus 280. Radiation is 200 times stronger than on Earth. Meteorites, the size of a pea, can puncture spacesuits. And yet scientists believe colonies are possible. Lava tubes will become shelters, ice will be a source of water, and solar panels on eternal hills will provide energy. But what if beneath the surface there are dangerous gases or unknown viruses frozen in the ice? And how will the human psyche withstand life under a dome where the sky is always black and the earth hangs like a distant blue sphere? And most importantly, why is this necessary? It's not just science. The moon could become a springboard to Mars, a factory for resource extraction, or even a tourist resort. But are we ready to pay the price? Or will colonization turn into a nightmare, like in movies about Martian disasters? Traces of aliens? Ufologists have been claiming for decades that the far side of the moon is an alien base. Allegedly, they found UFO ruins and even shadows of beings there. Scientists laugh it off. It's just a play of light and shadow. But what if there's a grain of truth to it? In the 1970s, Apollo 16 photographed an object resembling a tower 5 miles high. Later, NASA attributed it to a film defect. And in 2023, a Chinese lunar rover sent back images of stones, aligned in a row as if they were artifacts. A rational structure is most likely the result of erosion. But why do such anomalies only appear on the far side? Or do we just not want to see the obvious? There is no evidence yet, but the moon itself seems to present us with mysteries. Could it be a giant archive left by an ancient civilization? Or a mirror reflecting our fears? There is no answer yet. But if one day we find even one artifact, it will change everything. Even skeptics admit space is too vast to be empty. Lunar earthquakes. The moon seems dead, but its interior still stirs. The Apollo seismometers recorded thousands of tremors over the decades, some weak, like the steps of an ant, others with a force up to 5 on the Richter scale. Where do they come from? Some are caused by Earth's tidal forces, some by meteorite impacts. But there's a mystery. Deep moonquakes, whose source lies at a depth of 435 to 621 miles. No volcanoes, no tectonics. What then causes them? Scientists suggest core cooling or pressure of gases accumulated under the crust. But why do the tremors occur more often on the far side? Could it be that ancient magma chambers are still active there? Or is the moon like an old house creaking as it cools? The most eerie scenario is if the earthquakes are signals of something bigger, like the slow decay of the core or even the movement of unknown structures beneath the surface. Each tremor is a reminder. The moon is not just a rocky sphere, it is alive, in some strange, alien sense. And who knows what might awaken if we start digging deeper? We are on the brink of a new lunar era. Robots are digging the soil, telescopes are scanning the craters, and politicians argue about colonies. But the moon remains silent. It keeps its secrets under lock and key. Why are its two sides so different? Where does the water come from? What caused the magnetic anomalies? Each answer generates a dozen questions. Perhaps the far side is an archive where the history of the solar system is recorded, or a mirror reflecting our fears of the unknown. Or maybe a shield hiding what we are not ready to learn? But one thing is clear, the moon is not going to reveal its cards just like that. It waits for us to become wiser, braver, or more desperate. After all, its secrets are not just scientific puzzles. They are keys to understanding how planets were born, how light spreads, and what awaits humanity among the stars. The only question left is, are we ready to pay the price for this knowledge? Or, like children by the campfire, are we afraid to look into the darkness where the answers flicker? The moon is in no hurry. It has eternity at its disposal, and for us, time is passing. And while it passes, I have a question for you. Do you want to become part of cosmic discoveries? If you are skilled at editing videos, narrating text, or writing captivating scripts, head over to our HR bot via the link in the description. Together, we can investigate many more mysteries.